This video will talk about the how electricity is produced, and so let's just talk about a few things. So how is electricity produced? Well, you have two parts of a motor, right? So you have a stator and a rotor. So this is your stator. Okay, stator is stationary, it doesn't move, right? Static. This is your rotor. And the rotor basically will spin in a certain direction. Okay, so this part right here with the little with your little protruding lines here, this is your rotor, and it spins in this direction. The stator stays by itself. When this moves, these are basically your magnetic coils, right? These are your magnetic coils. Okay. So when the magnet moves over next to another magnet like such, right, as it's spinning faster and faster, it creates electricity. How does it create electricity? Well, your magnetic coils really look like this. These are basically, magnetic coils are called inductors. They induce, right? They take a piece of metal and they spin it around, and this is a coil. So this is spinning and it's overlapping with these other coils in the stator, which produces an electricity. So right here, here and here, it produces a current called I, right? I. So from I, what happens is that it produces a magnetic field, right? Because it goes through a coil. Once it's coiling, it produces a magnetic field. And this is a magnetic field going around like such. So as this goes up, this will produce a magnetic field going in this direction. It's a spiraling direction, right? This catches the magnetic field. So this is, let's say, when this is moving, the magnetic field, so you create as you're spinning, right, as you're spinning this, so when you're spinning this is going over one, so two magnets are going over one, right? So as this is spinning, then this produces a magnetic field. It catches the magnetic field like such, and then you have your current, right? So this concept is called induction, right? So what you're having is that you have a bunch of these magnets, could be coils or not coils, they're magnetized, and they're spinning, and as they overlap, so this is going at a certain velocity v, right? This is going at a v, like such, and as it goes over the coil, it produces a magnetic field, right? These are magnetized fields, and it produces a current, right? This concept is called Faraday's law. Again, like this would be, example of this would be, let's say, your stator. So your stator is here, okay? So your stator is here, and it's here. And we're moving this machine here, right? So as this is moving, okay, as this is moving, then as it passes from one magnet to the other, it produces a magnetic field, and it's producing a current, I, okay? As such, this is called induction. This process is called Faraday's law. Okay, that's important to know. All right. So now, how does this move? Do they have a bunch of magical leprechauns moving this? No, there's no leprechauns or anything moving it. It requires energy. Okay. So what kind of energy? So let's just say this energy has to burn. So let's talk about coal, right? Coal or fossil fuels, okay? So what happens in a coal and fossil fuel environment, right? This is basically burning, right? So we have a burn, right? So when it burns, it heats up the water, right? So it's burning like this, okay? And as it burns, it's heating up this steam, and this steam is water. So you're burning the coal to heat up the steam, heat up the water, and moving this rotor over, okay? Another example that also works is, you can call it nuclear. How does nuclear work? How does uranium produce electricity? Uranium does not produce any electricity. Uranium produces heat over long periods of time, 100 years, right? So as this is producing, what happens is the water is getting hot. As the water gets hot, uranium is producing heat, right? The coal is producing heat. So from the heat, you're heating up the water, produces steam, and it turns, okay? So now, how does your wind and hydro work, right? So how about wind? Wind, does it have to heat? No, wind is already moving this, okay? So as in a windmill, as the wind blows, it turns the rotor, okay? 4, how does hydro work? Like water, waterfalls or dams. So the way it works is that as the water comes down in a waterfall and creates a current in the water, it spins the rotor, which produces the electricity, okay? This right here is your clean energy. Okay, this is the clean energy that works in the turbines. This is your turbine. Okay, very important to know. All 4 of these two right here, heats up the water, produces steam, turns the rotor. Your wind and hydro turn the rotor by themselves, so they do not burn anything. That's why it's clean. So the backside, the negative side is that, you know, wind stops blowing. Where does the wind always blow? We don't know. It's unpredictable, right? So this is not sustainable. Hydrogen, I mean, it's not for hydrogen, I'm sorry, your hydro, well, we don't really know because, you know, whereas you have to have a waterfall or a dam. What if you don't have any water? How are you going to produce it? Right? So this is not self-sustaining, okay? Now, the other one is solar, right? So we have the last one is called solar. This is your solar sources, right? What happens in solar? Solar does not have a turbine. Solar simply has a concept called photovoltaic effect, okay? That means photons from the sun, when it passes the material in the solar panels, produces electricity, okay? And solar panels are roughly 10% efficient. Okay, it's got some problems. It's not it's not as nearly as effective as the other ones, right? And it's also poisonous. So basically, it is not, even though it doesn't have any emissions, it is toxic. So it's basically toxic land disposal, right? And what happens when you poison your land? It goes into the water supply. So you have to have a way to dispose solar, and we don't. It's not prevalent as it should be. Okay. So this is how electricity is produced. These are your clean types of energy. This is also your clean energy right here, and this is how the turbine works.